Students, welcome to my YouTube channel. Dhanesh here. Today I am going to discuss about Gauss's theorem. In the last video we were discussing about electric flux. We were discussing electric flux and we understood electric flux is the measure of the number of lines of force penetrating through a given area, and phi is equal to Ea cos theta. Here E is the electric field, A is the area, and we discussed in electrostatics area is a vector quantity and its direction is given by its normal. Flux is a scalar quantity. It's the scalar product of electric field vector and area vector. Theta is the angle between intensity of electric field and area. We discussed all these aspects. So what is this Gauss's theorem? So today we are going to discuss about Gauss's theorem. See, the electrostatics, we started from the charge. Charge is the fundamental quantity in electricity. From charge we defined electric field. From electric field we defined lines of force. Electric lines of force. Electric lines of force is an imaginary line drawn in such a way that the tangent to it at any point gives the direction of electric field. Electric field is the region around a charge where electric force of attraction or repulsion is experienced. From electric lines of force, I defined electric flux. In the last video, we discussed about electric flux. Electric flux is the measure of the number of lines of force penetrating through a given area. As discussed, phi is equal to E dot A. This is flux. So from charge, it's electric field. From electric field, we are discussing about lines of force. From lines of force, we discussed, we introduced the concept of flux. So charge depends on electric field depends on lines of force depends on flux. Then there must be a relationship between charge and flux. So this relation, Gauss's theorem gives the relation between charge and flux. So this is Gauss's theorem. So Gauss's theorem is the relationship between charge Q and flux phi. So what is Gauss's theorem? Gauss's theorem states that the total electric flux over a closed surface is equal to 1 by epsilon 0 times the charge Q. Here epsilon 0, you know it. Please watch the previous videos. Epsilon 0 is known as the permittivity of free space. Epsilon 0 is known as the permittivity of free space. So what is permittivity? As we discussed, permittivity is the ability to transmit electric lines of force. And in magnetic effect, we will learn the ability to transmit magnetic lines of force is known as permeability. We will discuss later. See, permittivity is the ability to transmit electric lines of force. So phi is equal to 1 by epsilon 0 times Q. This statement we call it as the Gauss's theorem. Again, I am changing that equation. See, phi is equal to 1 by epsilon 0 Q. In the Gauss's the flux can be written in integral form. Surface integral of E dot dA is equal to 1 by epsilon 0 times Q into Q. That means this is charge Q. Okay. So we discussed in the last video, surface integral of electric field is electric flux. Line integral of electric field is electric potential. In the next chapter we will learn it. So surface integral, integration is of different types. Line integral means a single integral, that is integration performed over a line. Double integral, or we can write it as surface integral integration, that means double integral. That is, this is over a line, this is over an area. If you are performing the integration over a volume, then it is known as the triple integral or volume integral. So this is surface integral, means here it is this is a double integral. Two integrals are there. That is surface integral. This is equivalent. You can write it as surface integral. So surface integral of electric field is equal to 1 by epsilon 0 times Q. Now I am going to give a proof for this Gauss's theorem. How we can prove Gauss's theorem? Its proof, it is proof of Gauss's theorem. See, you have a charge q. Q is the charge here, and there is a closed surface. Let's assume a closed surface around this charge q. Then what is the what we need to understand here is q is a charge, and let's assume that p is a point at a distance r from the charge. See, we are assuming a closed surface of radius r, then it can be a sphere. See, we are assuming a closed surface of radius r around the charge. So it is a sphere of radius r. Then the flux linked with this closed surface, that is closed sphere, phi is equal to E into A. Here theta is equal to 0 and cos 0 is 1, because the area is normal and the electric field is also in the same direction. Here theta is 0 degree. So phi is equal to E into A. So what is the area here and what is electric field? So the electric field due to a point charge at P due to Q is, it is 1 by 4 pi epsilon 0 into Q by R square. What is the surface area of a sphere? Here the closed surface is A. So it is 4 pi R square. So from this you can get it 4 pi and 4 pi cancelled, R square and R square cancelled. It is equal to 1 by epsilon 0 times Q. This is flux. This is Gauss's theorem. This is the proof. So phi is equal to 1 by epsilon 0 times Q. Once again repeating, see, Gauss's theorem states that the total electric flux over a closed surface is equal to 1 by epsilon 0 times the net charge enclosed by the surface. That we call it as the Gauss's theorem. And in integral form, Gauss's theorem can be written as, in integral form, it is written as surface integral of E dot dA is equal to 1 by epsilon 0 times Q. That is the integral form of Gauss's theorem. Now the proof, we can, you understood the proof as well. So in this video we discussed about the Gauss's theorem and its proof. In the coming videos we will be covering the applications of Gauss's theorem. Then the first chapter, theory, will be over. So this is the, I think this is the 7th video on 7th or 8th video, I believe, on electrostatics. So you can watch the previous videos as well, to get more clarity on electrostatics. We discussed Coulomb's law, electric flux, electric lines of force, electric field, all these aspects we covered. So thanks for watching. Please share, like and subscribe. Thanks a lot.